All right, let's talk about a topic that feels like it's absolutely everywhere these days: machine learning. And look, it's not some far-off sci-fi concept anymore. It's here, right now, and it's already shaping the world around us in some pretty incredible ways. I mean, just think about it for a second. How does your email provider just know which messages are junk and which ones are important? Or how about when your favorite streaming service suggests a new show, and it's so perfect it feels like it's reading your mind? We kind of take it for granted, but trust me, it is not magic. Yep, you guessed it. The answer is machine learning. It's the invisible engine running behind the scenes, powering so much of the smart, predictive, and frankly, kind of spooky good tech we use every single day. So what does that actually mean? Well, in the simplest terms, machine learning is a branch of AI where instead of writing out every single rule and instruction for a computer, we don't. We just feed it a ton of data and essentially let it figure out the patterns and rules for itself. Okay, now here's the more formal academic definition from computer scientist Tom M. Mitchell. And I know it sounds a little dense, but it's actually a perfect way to break it down. The experience, or E, that's just the data. The task, T, is whatever we want it to do, like, say, spotting spam. And performance, P, is how we grade it. The big idea is this: a machine is genuinely learning when it gets better at its job with more experience, which just means more data. Now, you hear a lot of terms thrown around, so let's get this straight. Think of artificial intelligence, or AI, as the big overall goal of making machines that can think or act smart. Machine learning is a huge piece of that puzzle. It's one of the main ways we actually achieve AI today. And then there's deep learning, which is a super specialized, powerful type of machine learning that's modeled loosely on the human brain. So we know what it is, but how does a machine, actually learn? It really boils down to three main ways of doing things. The big three are supervised, unsupervised, and reinforcement learning. First up, supervised learning. Think of this like studying for tests with flashcards. You give the machine a bunch of examples that are already labeled. This picture is a cat, that one's a dog. Its job is to learn the rules so it can label new pictures on its own. Then you have unsupervised learning. This is more like getting a giant mixed-up box of Lego bricks and being told, sort these. There are no instructions. The algorithm has to find the hidden patterns all by itself. And finally, my favorite, reinforcement learning. This is exactly like training a puppy. An agent tries things, gets a treat for a good move, gets nothing for a bad one, and over time it learns the best strategy to get the most treat. Okay, so those are the methods, that's the theory. But where does the rubber meet the road? This is where it gets really interesting, because it's happening all over the place. And I mean, the applications are just mind-bogglingly diverse. We're talking medical diagnosis, where an algorithm might spot something in an MRI that a human eye could miss. Credit card companies use it to sniff out fraud basically instantly. Self-driving cars, well, their entire existence is based on this stuff. And anytime you talk to a smart assistant like Siri or Alexa, you're using incredibly complex machine learning for speech recognition. And this didn't just appear overnight. The actual term machine learning was coined way back in 1959 by an IBM researcher named Arthur Samuel. The field really started to take off in the 90s when we got enough computing power to make it practical. But a truly massive moment was in 2016 when AlphaGo, a program using reinforcement learning, beat one of the world's best Go players. That was a game changer, proving just how powerful these systems could be. But, and this is a really big but, it's not a silver bullet. This technology is incredibly powerful, which means it also comes with some serious challenges and some really tough ethical questions that we absolutely have to talk about. I mean, it seems simple enough, right? Give a machine data, let it learn. What could possibly go wrong? Well, as it turns out, a lot, actually. Two of the biggest technical problems you'll run into are underfitting and overfitting. Underfitting is when your model is just too simple. It completely misses the point of the data. But the sneakier one is overfitting. This is when the model gets too smart for its own good. It learns the training data perfectly, including all the random noise and flukes. It's like it memorized the answers to the practice test, but didn't actually learn the material, so it completely bombs the real exam. And that leads to what's known as the black box problem. With some of the most powerful models out there, we can see the data that goes in, and we see the answer that comes out. But the reasoning, the why, is a complete mystery. Even the people who design it can't always tell you how it got there. And that's a huge issue, right? How can you trust a medical diagnosis from an AI if it can't explain its reasoning? But maybe the most important challenge is algorithmic bias. These systems learn from data that humans create. And, well, our data is full of our own societal biases. The scary part is, the algorithm doesn't just learn these biases. It can amplify them and apply them at a massive scale. For instance, if you train a hiring tool on past company data that favored men, it will learn to discriminate against women. We've seen it happen. We've also seen predictive policing tools that unfairly target minority neighborhoods because they were trained on biased historical data. So it really leaves us with this one big, final question to chew on. As these machines get better and better at learning from the world we've created, what are we actually teaching them? And more importantly, what are their decisions, their biases, and their predictions teaching us about ourselves? That's definitely something we're thinking about.